This webcast discusses how to complete experiments 1 and 2 in the Gravitational Force Lab. So I'm at step 10, where we're beginning to make our quantitative observations, and we want to be clear on the three things that we are able to change in this simulation. So if we look at that simulation, we can see that we can vary the mass of object 1, the mass of object 2, and also I can change how far apart they are, right? I can bring them closer or further apart. Okay, so those are the three things that we are able to change. Because there are three variables that can be changed, that means that we potentially have three independent variables that could affect the value of the gravitational force. And I want to understand how the gravitational force depends on all three of them. Therefore, if we want to conduct a controlled experiment, we will need to change just one thing at a time. And that means that we will conduct three different experiments. Now, in experiment 1, the thing that we will change is going to be the mass of object 1. So the mass of object 1 is our independent variable, the thing that we are purposefully changing. In the table, in your lab template, you see that at the top of the table there is a place to record the constants, the things that you are going to hold constant during this experiment. So even though the simulation tool gives me the ability to change mass 2 and the ability to change the distance between the masses, I'm going to choose values and hold those two things constant. And I want us all to choose random values here. So please use a number that is different than mine and different from the people around you. So I just happened to choose a mass for object 2 of 303 kilograms. And so that's what I'm going to hold constant. For the rest of this experiment, I will not change the mass of object 2. And I also happen to choose a distance between the centers of the masses of 6.6 meters. And so I will not change that distance anymore for this experiment. The only thing that I'm going to be changing is mass 1. Now, so the smallest mass that it will let me choose is 10 kilograms. And so the first thing that I did was I set my mass 1 to 10 kilograms, and then I have recorded the value of the force. And so I can see that, and I'm writing my force in scientific notation. So I can see I'll have to move that decimal point 3, 6, 7, 8, 9 places so that I will only have one number to the left of the decimal point. And so that's 4.642 e to the negative 9th. And I've recorded that here. Then I changed the mass of object 1 to 100 kilograms. I am not changing mass 2, and I am not changing the distance between them. I'm only changing mass 1. And now I have a different value of force, and I'm going to record that. So this is going to be 4.6424 e to the negative 8. And so I've recorded that. I recommend that you put this data directly into Microsoft Excel, because that's what we're going to use to make our graphs and do the linear regression, and that may save you some time. And so I'm going to go ahead I'm opening up a new Microsoft Excel file, and I'm labeling this data experiment 1, because we're going to have 3 experiments, so I want to be clear this was experiment 1. The constants are very important in this experiment. We will need the specific values of them later as we do our analysis. And so please be very careful to accurately record your constants. So I'm going to go back and just check them again to make sure, yes, my mass 2 is actually 303 kilograms, and my distance between the centers is 6.6 meters. Okay, so I've recorded my constants. Now I need to create a table in Excel. I always put the independent variable on the left and the dependent variable on the right. Here, my independent variable is the mass of object 1, measured in kilograms, and I've typed in the values of mass that were in that table. Okay, and now I'm recording the gravitational force. That is my dependent variable, and I am recording it in scientific notation here in this column. When you type a number into Excel in scientific notation, and I'm going to show you out here. So my first number is 4.642 times 10 to the negative 9th. So I'm going to type 4.642 e negative 9, and I hit the return key. So do you see that even though it might only show the first 2 decimal points, it has actually retained every number that I typed in? And you can see when you come up to the formula bar here on the screen that you could count these zeros and make sure that it really is 10 to the negative 9th, and it is. So that is how you put a number in scientific notation. Let me do one more. My second one here was 4.6424 times 10 to the negative 8th. So I would type 4.6424 e negative 8. Notice there's no space in front of the e or in front of the negative 8. And so Excel understands that as a number in scientific notation. Okay, I'm just going to delete those, okay, because I've got them typed over here. Pause this video and go get all of your data and put it into Excel. And then once you have your table in Excel, we're going to make a scatter plot. And so you will highlight the cells that have the numbers. Okay, you don't need to highlight the header, and you're going to insert a scatter plot. Okay, and once we have created the graph, we want to label it nicely, so I'm going to add axis titles. Okay, so let's see here. This would be, dependent variable versus independent variable. So this is gravitational force versus mass 1. And girls, because our constants are so important to us in this experiment, I'm actually going to put them in the title. And so this is going to be for mass 2 equals 303 kilograms, and r, that's a symbol for distance, equals 6.6 meters. I need to say equal 6.6 meters. Okay. So now I've got my constants also recorded on this graph. That will be a very nice idea. Okay, so my independent variable was the mass of object 1, and that was measured in kilograms, and then my gravitational force was measured in newtons. Okay, so I have this graph, which is going to be figure 1, and so I might want to add that to my title just so I don't forget that this is figure 1 that I'm going to later snip and put into my lab report. But then after we have this graph, we want to do linear regression. I mean, we have a very nice linear shape to this graph, which means that the gravitational force is proportional to the mass of object 1. But I'm going to go ahead and get linear regression for this. Okay, so I'm going to go up to the Data tab, and over on the right I see Data Analysis. If you do not see Data Analysis on your Data tab, you need to add in this this toolbox, and there are instructions for how to do that. In the References section of PowerPoint, there's there's a set of PowerPoint slides talking about how to use Microsoft Excel for physics. And near the beginning of that, it tells you how to get this data analysis tab. Okay, but I'm ready to do my linear regression. So I click on data analysis, and I'm going to choose regression from this list of statistical tools. It's about 3 or 4 down from where it starts you. Once I've chosen regression, I say OK, and it gives me a form that will have the instructions to Excel for what we want to do linear regression on. First, I'm going to choose the range of cells that contain the data that's plotted on the y-axis. In this graph, that is the gravitational force. So I click this arrow to go back to the sheet, and I'm going to highlight only the cells that have the numbers for gravitational force, and see how it's capturing the addresses, the cell addresses of that information. Then I click here to go back to the form. Now I want to do the same thing, but I want to give it the data that's on the x-axis, which is the mass of object 1. So I'll come back to the sheet and highlight the numbers for the mass of object 1. We're almost through, but before we say OK, please make sure that you check the boxes for the residual plots and the line fit plots. Okay, then we can say OK. It creates a new sheet in our workbook, and everything is scrunched up in this grayed area, so you can kind of see that the columns are not wide enough. So in order to see everything clearly, I'm going to go to the Home tab, and over on the right there's a drop down called Format, and I want to choose Auto Fit Column Width. Okay, that just makes every column as wide as the data in it. I'm going to grab each of these graphs in the upper left-hand corner and just move them so that I can see them. And I want to just check. My residuals look nice and random. No real discernible pattern. That's good. The line fit plot is plotting the predicted, that means the values that the equation is predicting, and the actual data points. This line fit is so good that I really can't even see my actual data points. They're being covered up by the predicted values. That's a good sign. My R squared is a 1, which is perfect. So the data that I was trying to do regression on was clearly linear, and so this equation that it's going to give me is a good match for my data. It really accurately represents that linear graph. And this is the number that I'm looking for, so I'm going to highlight that with yellow. The number to the right of where it says x variable 1, that is the slope of my graph. Now notice that the y-intercept, I didn't highlight it, but that's the number next to intercept. It is very small. It's -1 times 10 to the -13th. So it's essentially 0, and I'm just going to ignore that y-intercept for our purposes. Okay, but I do want to record the slope here. So I've got 4.642 times 10 to the -10th. And so I would write that here, 4.642 times 10 to the -10th. And I need to get the units of that slope. Now, in my, if I go back and look at the graph, I had gravitational force measured in newtons versus the mass of the object 1 measured in kilograms. The slope is the change in the y over the change in the x, so the units here are newtons per kilogram. And so if I wanted to explain the meaning of that slope, I want to use a phrase that says for every additional, and I want to talk about for a 1 unit change in my independent variable, how does the dependent variable change? So for every additional 1 kilogram of mass added to object 1, the gravitational force increases, right? I can tell that it increases because this graph has a positive slope. The gravitational force is increasing by 4.642 e to the negative 10th newtons. So that would be what this slope means. And so then we could develop a physics equation for this. So our independent variable here is the mass of object 1. And I'm going to call that mass 1. You know, big M with a 1 subscript. My dependent variable is the gravitational force. And, you know, we've always called that F with a G subscript. So the gravitational force equals 4.642. There we go, 4.642 times 10 to the negative 9th. Oh, I'm sorry, 10th, I guess. Newtons per kilogram times the mass of object 1. Okay. Okay, so we have now completed experiment 1, and experiment 2 is quite similar. You should choose different constants for experiment 2 than you chose in experiment 1. Do not use the same mass and the same distance between the two objects in experiment 2.